Good evening, everyone, and welcome to today's Amateur Radio Technician class, session number 13. So when we look at our curriculum, we notice that we have progressed nicely through all of the topics, and after today, we have one more topic to cover to complete the technician class. Last class, we looked at the following topics. We dealt with what a transceiver is, a transverter. We looked at what an RF power amplifier was. We looked at some specifications such as sensitivity and selectivity. We looked at stages such as the mixer, the oscillator. We looked again at modulation. We discussed RF interference, its causes and remedies. We looked at filters. We considered what are Part 15 devices. We discussed distorted and noisy audio, also over deviation. We looked at some instruments such as the voltmeter, ohmmeter, ammeter. We looked at what rosin core solder was. We discussed what a cold solder joint is, and we stopped on page 59 of the No Nonsense Guide. We did not have any questions from the last class, so moving right along. So we are looking at the concepts that we might have touched on previous sessions, but in a different way. We are looking at what a VHF, UHF transceiver is, and in particular, using that to connect to what is a repeater station. So a VHF, UHF transceiver is the radio that we have been talking about all throughout this class. So on the left-hand side here, this is an example of a VHF, UHF transceiver. It could be installed in a mobile, a car, it can be installed at a home, it could be installed during a portable operation. So we talked about what repeaters are and repeater stations, but we just want to re-emphasize that if this here is our repeater station and it's located on, let's say, the top of a hill somewhere, it could be Cumberland Hill, it could be San Salvador Estate in Central, it could be Pepper Hill, it could be Tortuga. Those are high locations. Fort George, those sorts of places, repeater stations tend to be installed. And the reason we have those repeater stations is so that we get wide area coverage. On its own, when we use simplex transmission, which is radio to radio, we don't get much coverage, maybe a couple of kilometers at best. But if we want to get tens of kilometers or even hundreds in some cases, we need to use a repeater. So we have a radio. This is a handheld radio here. And we wish to talk to another handheld radio on the other side of the country. They will not be able to talk directly to each other because they're too far away. So we employ the use of a repeater. But we need to realize and remember that when we use a repeater, as opposed to when we're talking radio to radio, we use one frequency or simplex, one frequency to go. The person receives on that frequency, and when they transmit on the same frequency back to the first person. So that is simplex. But with repeater operation, we don't just use one frequency, we use two frequencies. One frequency as the go frequency to the repeater. And when we go to the repeater on that frequency, the repeater transmits or retransmits on another frequency to all the other listeners. So that's where the two frequencies come in. One frequency from the radio to the repeater, and the other one is used for the repeater to transmit. It cannot be the same frequency because you cannot be receiving on the same frequency and transmitting on the same frequency at the same time. So you need two frequencies for repeater operation. In amateur radio, there are three different categories that you will be asked in your exam about that we look at now: the repeater, auxiliary, and space station operation. So we talked about what a repeater station is, right? You transmit to the repeater and the repeater transmits back out. It's similar to like a cell tower. That's actually what cell towers are. They are repeaters. They will receive a signal and transmit it out. They will also talk to other cell towers. But this is a repeater scenario. It's automated. That means there's no operator at the repeater, and it can also operate unattended and 24/7 operations, right? So that's the repeater station. But we also have another type of station in amateur radio called an auxiliary station. An auxiliary station is also unattended. Technologies such as crossband repeat. So we may have this radio in a vehicle sitting, and we may wish to talk to someone. The radio itself may not be able to get to the repeater, but through crossband repeat, we use our handheld radio, talk to a radio, for example, in our car, and that radio in our car will transmit to the repeater. So that is also an automated form of operation, and that is considered an auxiliary station. There are other types of operations under auxiliary stations, but such as if you're operating a remote base, you are not at home and you wish to operate remotely, that is also considered auxiliary operation. But notice the concept, we are not at the radio. So it is a form of remote operation. So apart from repeater operation, we have auxiliary station. And the last one that we talk about is also a form of repeater operation, but it's called space station. Instead of the repeater being on top of a mountain top, or in the case of an auxiliary station at a home or in a car, the space station repeater is actually in the sky. It is in space. It is a space station or a satellite that we are using as a repeater. So we transmit from the Earth to the satellite, and then the satellite repeats back on its signal to the Earth. So that is considered space station. So we need to know these three types of operations for amateur radio. Yet another concept that we need to be aware of. So the previous slide, we saw one repeater. So I have a radio and I'm talking to one repeater, and that repeater's transmission goes to another radio that someone is listening on. But we can also link repeaters together to have even wider area coverage, not just in one country, it could be across several countries as well. We can link repeaters in different parts of the world. We can use radio to do so, but we can also use the internet to link. So notice this diagram here. This cloud in the center is the internet, but notice we have a repeater here. The repeater is connected to a computer gateway that goes to the internet. This may be in Trinidad. We may be in Tobago and have the gateway computer there connected to the internet, and that gateway computer connected to a repeater station. And this person with their handheld radio in Trinidad is transmitting to this repeater in Trinidad, but through the internet, it goes to a computer in Tobago, and that computer goes to a repeater in Tobago, and they were able to talk to someone in Tobago. An operation that would be very difficult to do otherwise is enabled through links such as the internet, and we consider that operation to be linked repeater network operations. We discussed the concept of repeater offset before. Remember, we had talked about 600 kilohertz, the difference between the transmit and the receive for 2-meter operation that is standard in amateur radio. So we are just going to pounce on this a little more to illustrate the concept one more time. So I have my handheld radio here, my walkie-talkie, my HT, and I wish to talk to someone, and I have to program my radio with the correct radio frequency. If I'm going to use a repeater, I need to know the frequency that the repeater is on. So the repeater may be on what, 146.760. That might be the repeater frequency, but I also have to transmit. Remember, with repeater operation, it's 2 frequencies. So we have a transmit and a receive. It is conventional that the 2 frequencies have a relationship. And in amateur radio, for the 2-meter or the VHF part of the band, we normally use plus or minus 600 kilohertz. So whatever the frequency is, the transmit is 600 kilohertz away from the receive. So we just need to know that for 2 meters, when we're programming radios for amateur radio, the separation or the difference or the offset is 600 kilohertz for the 2-meter band. The 70 meter band, also known as the UHF band, that separation is actually 5 megahertz, but it's plus or minus 5 megahertz. So whatever the repeater frequency is, the transmit to the repeater will be either 5 megahertz lower or higher compared to the transmit frequency of the repeater. So just bear in mind when we talk about two frequencies, one is with respect to the other separated by a certain amount of frequency, which is 5 megahertz per centimeter. And we have two diagrams to show here. In this case, for 2 meters, this radio is transmitting on 146.160, but it is receiving on 146.760. Notice the other radio operator also has their radio configured in the same way for the frequency. The repeater, however, will be the opposite configuration. So we need to worry or concern ourselves, how do we program our radio? And we need to know these repeater offsets. We have a similar diagram that shows what happens for the 70 centimeter band. We also discuss the concept of PL, and PL is short for private line, and CTCSS, continuous tone coded squelch system, also known as tone. We need to know what tone is because we need to program our radio. Apart from programming the receive and transmit frequency on our radio, we also have to consider whether the repeater that we want to talk through also requires a tone to be programmed in the radio. Because if it does require a tone and we do not put that tone in, when we press our push to talk to transmit, that repeater is going to ignore us because it is not getting, apart from our audio, it's not getting that subaudible tone accompanying our audio. So we need to know if a repeater requires a tone to activate the repeater, what that tone is. So we note that a tone is a subaudible tone and it opens the repeater squelch. Now, the tones itself, these are the various tones that you'll find in a radio. You don't need to learn this for the exam, but we like to give something extra for the class. So these are the various tones, analog tones that we use in our radios when we're programming. So apart from programming the frequency, we also need to program the tone. In other words, the radio and repeater tone must match if we are using that type of tone. Note that one of the reasons we employ tones is that it helps with interference. Repeaters are often located with other repeaters and other sources of noise. Those hills tend to be very hot when it comes to RF or radio frequency, a lot of radio frequency interference. So to discern from a legitimate signal, we tell the repeater, only activate if you hear this tone coming along with the person's transmission. So that is why you need to program your radio with that matching tone so that the repeater doesn't trigger on a false signal. It might be interference and then the repeater is keying up unnecessarily. Your radio signal going to the repeater needs to have that tone going along with your voice to activate the repeater or open the repeater squelch. Now, as hams, we often have to troubleshoot things. Things can go wrong. Remember, we talked about a guy by the name of Murphy. Well, Murphy is often around, and we have to troubleshoot repeater access. We are unable to access the repeater. What could be some of the reasons? The first thing that you need to know for the exam is maybe we are using the wrong offset. Remember we said for 2 meters, it needs to be 600. What if we made a mistake of using 500 as the offset? I don't know, we shouldn't do that, but you can actually, as a ham radio operator, change the offset on your radio. What if you inadvertently change it to 500? When you transmit, you are transmitting on the wrong frequency. So that is one of the possible causes that you cannot access the repeater. You are using the improper transceiver offset. Another reason is that your transceiver is not sending the correct tone, right? Or the CTCSS, the analog tone, or also called the PL tone, right? We did not discuss what DCS is, but DCS is a digital tone. It stands for digital coded squelch. It's a kind of CTCSS, or it's similar to CTCSS, but instead of it being analog, it is a digital tone, but it's not very popular. But some repeaters may use it. I don't know of any in Trinidad and Tobago that uses it, but it could also be that if the repeater requires a DCS tone, you do not have the proper DCS tone program. So in the same way that you may have forgotten to program the PL tone or the CTCSS tone on your radio, if the repeater requires it for access, you may have forgotten or programmed the wrong tone for your radio. So bear in mind, those are two reasons as well that you may have trouble accessing the repeater. And you certainly need to know these for your exam. Also, it could also, if you don't have proper access, your signal is weak and all of that, right? So you're talking to another person and you're trying to use the repeater, but they're not getting good access to the repeater. If they happen to be close to you or close enough to you, you could actually listen to the repeater input frequency and you might hear them. In other words, they're not making it to the repeater, but their transmit frequency on their radio, they're close enough, you could listen to the repeater input frequency. So you could hear that person's transmission directly. So that's one technique. We often talk about a function on a radio called reverse split. That is the button that you will press on your radio. It's called reverse split if you want to listen to the input of the frequency, the input of the repeater frequency. In other words, if it is that we want to use this technique, a person is not making it strong into the repeater, and we want to hear if we could hear their input, the button that we press on the radio is called reverse split. Now, sometimes a person say, you know, your transmission is sounding distorted, or your voice is breaking up or cresting on the peaks. You're sounding very distorted, or they're not hearing you when your voice goes very loud. The reason could be that you're over-modulating, you're driving too loud, you might be speaking too loud. So you need to know that if somebody tells you that you're breaking up because your transmission, you know, on the peaks of it, they're missing it, you can back off. You remember we talked about that technique last time. You move the radio microphone a little away, a couple inches, or you move your face or your voice a little away, or you can speak a little softer, slightly softer, and that may improve. So these are techniques in case you have problems that you can use. Again, these are on the exams. So we come to some nitty-gritty operating procedures. So persons who are in the class that are already radio operators, maybe you're a React operator, and you're already using radio operations. These may hit home with you because these are also the same types of techniques that we recommend for proper radio operating practice. So when we are making a call to another station, I wish to call someone. So my call sign, amateur call sign, is 9 Zulu 4 Romeo Golf, or 9Z4RG. We use phonetic alphabets when we are calling out our call sign. But I wish to call my good friend, Jeff. He is 9Z4 Charlie Golf, 9 Zulu 4 CG, or 9 Zulu 4 Charlie Golf. If I want to call him, there is a way that I will call him. I use my handheld radio. I want to get him on the repeater. You know, I know his call sign. The way we do it is we say the station's call sign first, and then we identify our call sign. It's not the other way around. Sometimes you hear people saying so-and-so to so-and-so. We say the word from can be helpful, or a helpful reminder. Always think of the word from. So example, I'm going to call Jeff. 9 Zulu 4 Charlie Golf, 9 Zulu 4 Romeo Golf. Another way I could make that call is say 9 Zulu 4 Charlie Golf from 9 Zulu 4 Romeo Golf, right? So that's why I say we can use the word from as a reminder. If you are having to say to, you know you're kind of not meeting the mark at all, right? So it's the called station call sign first and your call sign after. That is the proper radio operating practice and protocol. Other station call sign first, your station call sign after. I'll fix these arrows for the slides. If you are listening on a repeater and you want someone, you know, who might also be standing by on the repeater, you know, you want to let them know that you're there and you're hoping to have a conversation, or what we call a QSO, you want to have a conversation. You don't know who is out there. So you're not going to transmit and say, anybody out there I want to talk with. No, you don't do that. The protocol or the operating procedure that we use as amateur radio operators is we give a brief statement to say that we are listening on the repeater and we are looking for contact. So one way to do that is to simply state your call sign. So for example, I can say, this is 9 Zulu 4 Romeo Golf listening. As simple as that. Sounds very professional. Or if you want to abbreviate it, you can say 9 Zulu 4 Romeo Golf listening. That's all. You could throw in these extra 2 words. This is 9 Zulu 4 Romeo Golf listening. That is how you professionally go onto a repeater and tell someone that you are there and you're hoping to make a contact. And if Jeff 9 Zulu 4 Charlie Golf is there, or 9 Zulu 4 Delta Alpha Alpha, my good friend David, if he's listening, he will get back to me. He'll say, hey, Robbie is on the air, he's on the repeater, and he's looking for contact. And they will call me, all right? Notice that even if you are testing your radio, let's say you want to check to see if your radio is accessing the repeater, it's not a good idea to just key the repeater or press the push to talk on your radio, what we call chunking the repeater. That is not the best way to do it at all. It's considered a little bit rude, right? It's a little bit inappropriate. The way to test, we say that once you're transmitting as an amateur radio operator, you need to identify your station. So if I'm going to do a test to test my access to the repeater, instead of just keying or pressing the push to talk and releasing to see if I hear the repeater return, I'm supposed to key my push to talk and say, this is 9 Zulu 4 Romeo Golf testing. That is the proper operating procedure to do testing. And note, it's important to always identify your station, even when only performing tests. Again, exam questions, right? We say that a basic tenet of amateur radio is to operate courteously and to avoid interfering with other stations. But what happens if you actually, someone says, hey, you're causing interference? Common courtesy should prevail, and note that no one has any absolute right to amateur frequency, right? So no one can claim, I have a right to be on this frequency. No, it is better to be courteous and work things out. All right, so a little more in terms of operations, right? So we talked a bit about simplex operation. Simplex operation is transmitting and receiving on the same frequency. So 146.520 megahertz is a frequency. All right. As a matter of fact, that is the national calling frequency on VHF. So if I am transmitting on 146.520 and the other person is also transmitting on 146.520 and I'm hearing them on that frequency and they're hearing me on that same frequency, that is considered simplex operation. Remember we have said repeater operation or duplex operation is operating using two separate frequencies, right? So please, well, duplex in this case here, we're referring to repeater operations, right? So simplex is using one frequency to communicate. Notice it is short range because we're not using any repeater in between. So we are limited by line of sight or whatever the frequency band that we are using limitations bring. Note that you can use it so that if two operators are close by, you can talk to each other without tying up the repeater. In other words, other people may need to use the repeater to talk. They may be far away from each other, but if two of you, you and your good friend, you're close by, let's say both of us are in around Port of Spain, yeah, I think that's fairly line of sight. We can talk to each other on simplex, and have a good transmission. So if that is the case, use simplex and don't tie up the repeater unnecessarily. Note that the national call-in frequency for FM simplex on VHF or the 2-meter band is 146.520 megahertz. You need to know that for the exam. So memorize, please. All right, so we now go to HF operations. So I'm on HF, so this is an HF radio and this is the microphone, and I wish to talk to someone on an HF frequency. So I switched to frequency, maybe 7.159 megahertz, lower sideband. That's the frequency I plug into the radio, and I want to call my good friend David, right? I can make a call, but let's say if I don't know who is on the air, maybe David is not around, maybe Jeff is not around, and I don't know if they are around, and I just want to put out a call. Again, I don't just simply go on the air and say, hey, anybody listening? I want to talk. No, we do not do that. Proper procedure is we call CQ. In amateur radio, when you want to contact another station on HF, we call CQ. It means calling any station. That is what CQ means. And this is an example of if I am to make that call, I press my push to talk on the radio and I say CQ, CQ, CQ. This is 9 Zulu 4 Romeo Golf. That is how I call, and then somebody may hear me and they will get back to me. All right, so that is how we make calls on amateur radio. A guideline when choosing an operating frequency for calling CQ, we need to listen first to make sure that no one else is using the frequency. We don't just start to talk. And after we listen for a while, the next step is that we should ask if the frequency is in use. After we do that, we then make sure that we are using our assigned frequencies that we are allowed to use. So always check. So if I'm using 7.159, I know that is part of the frequencies that I'm allowed to use. I can use it. Now, when we are replying to a CQ, so someone transmits CQ, you know, my good friend replies to a CQ, right? How you can do that is by transmitting the other station's call sign followed by your call sign. Again, remember this from previously. It's always the other station's call sign than yours. So for example, 9 Zulu 4 Charlie Golf, this is 9 Zulu 4 Romeo Golf over, right? So notice this little pro word over, that is like punctuation telling that person that you have finished speaking and it's over to them. So it's like punctuation radio operations. In amateur radio, especially if you're doing Morse code, we have something called the Q codes or Q signals. So because Morse code is dits and das, you know, we want to abbreviate and shorten the transmission. So they use Q codes, and that's the purpose. Sometimes they use to shorten the number of characters sent during a Morse code contact. Amateur often use 3-letter combinations called Q signals. So it's a 3-letter combination and it begins with the letter Q. So two of the Q codes or Q signals that you would need to learn and memorize for your exam is QRM. And QRM simply means that you are receiving interference from another station or other stations. QSY means that you are changing frequency. So these are two Q codes that you need to learn for your exam, QRM and QSY. A band plan. So as an amateur radio operator, you are given an allocation of amateur radio frequencies, a range. But within that range, there are several frequencies. So band plans are developed. Sometimes the IARU, the International Amateur Radio Union, develops band plans. And what a band plan is a voluntary guide for using different modes or activities within an amateur radio band. So for instance, on the VHF part of the spectrum, certain parts of the frequencies are allocated to satellite. So we don't interfere with satellite. Some of them are allocated to simplex operations. Some of the frequencies are allocated to repeater operations. Some of them are allocated to hotspots. Some of them are allocated to beacons. So even though as a ham, you are licensed for parts of the spectrum, some of them are allocated to different types of activities or services. Some of them are considered to be the phone part of the spectrum. Some of them are allocated to digital modes. Some of them are allocated to CW, some FT8, those sorts of modes. Some of them are allocated to voice only. Some of them are allocated to a combination. So you need to know what a band plan is, and it's a voluntary guideline. We now talk about emergency communications, abbreviated Emcomms. There are organizations under amateur radio that provide emergency communication services. For your exam, you need to learn about two of them. One is called ARES, which means Amateur Radio Emergency Service, ARES, at least that's how it's pronounced. And ARES are licensed amateurs who have voluntarily registered their qualifications and equipment for communications duty in public service. Right? So this here, for example, you know, would be what an amateur radio might put together as a Go kit or an Emcomms kit, emergency communication. You just close it up, grab that and go and deploy for an emergency. We had Hurricane Laura go through the States recently, and you have a lot of Emcomms or ARES persons that would have been responded. The other one is called RACES, Radio Amateur Civil Emergency Service, pronounced RACES. So the first one was ARES, and the other one is RACES. Again, you need to know this for the exam. And RACES, all of these 3 bullet points here. It's a radio service using amateur radio frequency for emergency management or civil defense communications. It's also a radio service using amateur radio stations for emergency management or civil defense communications. So notice this is frequencies, this one says stations. RACES is also an amateur emergency service using amateur operators certified by a civil defense organizations as being enrolled in that organization. So this is what RACES is as opposed to ARES. But notice there's a commonality between RACES and ARES, and that is both ARES and RACES organizations may provide communications during emergencies. And these are the logos for ARES and RACES. When an emergency occurs, let's see this question here. Yes, that's a very good question. Thank you very much, Andrew. Yes, in Trinidad and Tobago, we don't have ARES or RACES because we are studying amateur radio exams out of the US. ARES and RACES exist in the United States. So yes, you can say that REACT does in fact perform some of those services because within REACT, there are amateur radio operators, but also we have other amateur radio clubs such as TITAS, which is the IARU organization in Trinidad and Tobago, and they also perform as amateur radio operators these functions. Again, we are talking Emcomms or emergency communications. So anytime you hear about it, it's under the concept of Emcomms or emergency communications, which is ARES, RACES, or TITAS in Trinidad and Tobago, and REACT in Trinidad and Tobago perform Emcomms functionality. Very good question, Andrew. Thank you for it. So we were saying that when an emergency occurs, it is common for amateur radio operators to do nets or have a network. So REACT members who are on this course already knows what networks are. But we need to know for the exam that the net is led by a net control station. That operator who say this is REACT 104, this is 9 Zulu 4 Romeo Golf, net control. That is the net control station, and all traffic needs to go through net control if it's a directed net. The net control station, or NCS, makes sure that messages are passed in an efficient and timely manner. So that is like the chairman or the chairperson, I should say, of a meeting. That person regulates the flow. Net control station. And here's a net control station operator doing net control duties with his equipment. All right. Now, stations other than the net control stations, that means all the other operators, they are set to check into the net. In other words, the net control station will say, okay, do we have any check-ins or do we have any acknowledgements? So everybody else, apart from the net control station, checks in to the net. And they are also expected to remain on the frequency without transmitting until asked to do so by the net control station, until being called upon. Now, if you have to get immediate attention of the net control station, meaning that there is an emergency, there is a way to do it. What you do is you key and you begin your transmission by saying either priority or emergency, followed by your call sign, right? So that is what you need to do. Example, emergency, 9 Zulu 4 Romeo Golf. It's as simple as that. And the net control station will answer you. The groups in Trinidad and Tobago that offer emergency services, example, REACT, recognized or acknowledged by ARES or RACES. Yes, in the United States, certainly yes, but again, it's jurisdictional. So RACES and ARES are jurisdictional within the United States. So yes, also REACT cooperates with ARES and RACES in the US. All right, so we'll come back to that question in a bit there, Colin. Thanks for the question. All right, so we need to note that even in emergencies, you must follow the rules or the FCC rules. That is mandatory. However, there's a little caveat there where we say that FCC rules always apply to an amateur radio station, but in an emergency situation, you are allowed to do things, especially if you have to save a life or protect someone or protect property. You can operate on frequencies that you may not have normally been able to operate on. So if you're a technician class and you have to save a life, all right, you may not have HF privileges, but in an emergency or a declared emergency, you will be permitted as a kind of Good Samaritan type operation, you know, about the Good Samaritan law where first aiders, you know, if you assist someone, you know, it's an emergency and therefore you are often permitted or it's permissible to do things that you may not be able to do otherwise. So please note, even in emergency, you must follow FCC rules. But note that there are some exceptions in an emergency when you can operate out of your assigned band. But please don't do it normally or usually. You can get into trouble for doing so. Right, so also continuing with emergency communications networks, Traffic is a term that we use. So when we're on the radio and say, okay, do you have any traffic? No, we're not asking you to look out the window or if you're mobile to tell us how many cars on the roads and if it is heavy traffic or low traffic. That is not what we mean when we ask about traffic. Traffic is the actual messages or formal messages that are exchanged with the net control stations or between net control stations. So when you talk about traffic, traffic simply means messages, not vehicular traffic. One of the good characteristics of proper traffic handling, in other words, message passing, is passing messages exactly as received. So as radio operators, that is one of the key things that we must do. Develop that skill, that competence in message handling and passing messages properly. And one of the techniques that is used to ensure that those messages are properly passed, especially if we are using voice modes or what we call phone operation, is to use spelling via the phonetic alphabet. So for example, if I'm saying there is a fallen electricity line on Park Street, somebody say, is it Hart Street? No, I say it's Park Street, but remember in radio, the signal may be soft or there might be distortion, there might be noise, or it might be a low signal. The person cannot tell I'm saying Park Street. They are hearing Hart Street. I'm saying no, Park Street. They're saying, is it Hart Street? So what I do, I spell park. I say, I use the phonetic alphabet, which you're seeing represented in one form and fashion on the right-hand side here. The first letter is the letter that we are looking at. So if I'm spelling Park Street, I say Papa Alpha Romeo Kilo, P-A-R-K. Each of these letters, the phonetics are supposed to sound significantly different from any other one. So when I say Papa Alpha Romeo Kilo, the person might say, oh, Park Street, because Hart Street is Hotel Alpha Romeo Tango. And Hotel Alpha Romeo Tango will sound probably quite a bit different to Papa Alpha Romeo Kilo. So the person might say, okay, no, they're not saying Hart Street, huh? I'm not hearing any tango, I'm hearing kilo. Also, it's probably Park Street. So to properly pass messages, we have to utilize all the tools and techniques. And this is what training is. As React members, we do this training for message handling. And as amateur radio operators, it's part of the proper protocol and discipline for message passing. All right, let's see if we can continue and get through this material. So we talked about message handling. So for formal traffic messages, you need to know that there are four parts. We have the preamble, we have the address, we have the text, and we have the signature. Now the preamble is simply the information that you use to track messages. But also part of the preamble, we have something called the check. And a check is the number of words or word equivalents in the text portion of the message. We have a radiogram here and we'll see that in a bit. The address is simply the name and address of the intended recipient. Who is it going to? The text, well, that is the actual message that you want to get across. And then the signature is identifying who the originator or the sender of the message is, right? And if we look at a standardized ARL radiogram, we will see here at the top, we have the preamble. Notice that we have a check as well. And notice that the check says 15. So we expect this 15 here means that we have 15 words in the message. And you could check it here, 1, 2, 3, 4, 5. 5 times 3, 15. So there are 15 words in here. So that is the check to tell us that in the message, there are 15 words. So that's the preamble. This is the check that's part of the preamble. This is the address to whom the message is going to. Here is the text. This is the body or the actual message itself. And this is the signature, who is the originator. All right, so at this time, let us take a 2-minute break. And we will come back to the material. All right, so 2-minute break. Okay, welcome back everyone. So continuing, we also talk about satellite operation as amateur radio operators. Satellite operation, because we do in fact communicate with satellites. Remember we had said that we have satellite operation and it is those satellites carry repeaters. So they are basically repeaters in space. And because they are repeaters in space, they are repeaters. So you have two frequencies. You have what we call the uplink frequency and the downlink frequency. So one frequency is the go and the other frequency is the frequency that comes back to you. Normally for satellites, the uplink and the downlink frequencies are in two separate bands. Sometimes you have the UHF band as the uplink and the VHF as the downlink. Sometimes it's the opposite. But the uplink frequency is the frequency which you transmit to the satellite. And that is the frequency that the satellite receives your transmission on. So that's considered the uplink frequency. The downlink frequency is the frequency that the satellite transmits and you receive. Note that with the technician class license, you can communicate with satellites. So some people say, wow, I thought I had to get general and extra and so on. No, because the satellite operation is in the UHF and VHF band, which you have access to as a technician class licensee. So technician or higher class gives you access to the satellite operation. And amateur radio operators or stations may make contact with an amateur radio, another amateur radio operator on the International Space Station. And the bands that are used are the 2 meter and the 70 centimeter band. So those are the two bands that are used for satellite operation. We cannot use HF. Remember when we looked at the ionosphere and we said that the signals bounce off the ionosphere, it's refracted or we say sometimes reflected. Well, that's why we can't use HF. We have to use VHF and UHF because those are the signals that penetrate and go out into space. So that's the reason why we use 2 meter band or VHF and 70 centimeter band or UHF. So you're seeing where the importance of knowing the 2 meter band and what frequency it is. Those tables that we had several classes ago comes in, because that is important for us to understand the spectrum utilization. We mentioned this a little while ago, that you can use the UHF band or the VHF band. Well, U/V mode or UV mode means that the uplink is the 70 centimeter band or UHF, and the downlink is the 2 meter band or VHF. So the clue to it here, the U here in the UV is UHF, so that's why I put it in brackets. And the V here is VHF. So if you see U/V, it means UHF, VHF. If it was the other way around, by the way, V/U, it will be VHF, UHF. But for the purpose of the exam, you will get a question about UV mode. And you need to know UV mode is UHF, VHF, which is the 70 centimeter band uplink and the VHF band as the downlink. So if we look at the satellite here, we notice that there's an uplink frequency and a downlink frequency. All right, that's UV mode. Also note that for satellite operation, you can use these 3 common modes: SSB, single sideband; FM, frequency modulation; CW, also known as continuous wave, or data. So these are the modes that's commonly used when we are communicating with satellites. Note that for satellite operation, as is for all amateur radio, this is not only for satellite operation, amateur radio across the board, use only as much power as you need to make the contact. In other words, do not use any more power. The way they have it in the question pool is to use as much power as is needed. But I like to say, use no more power than you need to use. All right, if you only need 2 watts, why run 50 watts, right? You put more stress on your equipment, you use more power, you pay more electricity bills, that sort of thing. Only use as much power as you need. And that is also a part of amateur radio operating practices. understanding and learning how much power you need to use. Because as an amateur radio operator, when you get your license will tell you how much power you can use. If you get a local license issued by the Telecom Authority of Trinidad and Tobago, TAT, that page that shows your license call sign and the bands that you could use will tell you the power, but you don't have to use. If it says you can use 1500 watts on HF, you don't have to run 1500 watts. You may not even have 1500 watts. Use only the amount of power you need. And that is especially important for satellite operation, because when you do more power than you need, you might cause other people who are trying to use the satellite, their signal may be descends because the satellite receiver is hearing your strong signal and is not able to get their weak signal. So only use as much power as you need. Using too much ERP or effective radiated power on a satellite will result in blocking access by other users. So that's just another way of restating what I just mentioned to you. So you need to know this part for your exam. If you use too much power, you could block access by other users, right? Or from other users. A satellite beacon. So apart from the satellite that's out in space, and we said it's a repeater in space, you know, you send a signal to it and it sends it back down. Apart from that, satellites also contain a beacon. It transmits continuously, blip, 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 and it sends a signal that contains what we call telemetry information. So the satellite beacon is a transmission from the satellite that contains status or status information. It tells about the health and the status of the satellite itself, what the temperature is, what the voltage of the battery is it doing well, you know, etc., etc. Is the transmitter on? All those are things that it might send. And anyone can receive that signal or telemetry signal from the satellite. Again, these are in an exam question, so you need to learn this about a satellite beacon. To judge whether your uplink power is neither too high nor low, the technique is to make sure that your signal strength on the download is about the same as the beacon. So that is one technique to know whether your transmit power or your uplink power is just about right. Check the beacon signal, and if your signal is about the same, then it's just about right. Now, it's not too high and it's not too low. You need to know what LEO or low Earth orbit is. LEO, that is the part of the space that the amateur satellites are usually located, and the altitude of those satellites is between 99 miles and 1200 miles. So this is where LEO is. You also have medium orbit, and you also have geostationary orbits around the Earth. So low Earth orbiting satellites, that part of the space is where amateur radio satellites are. They move around, all right? They're not geostationary. Now, how do you track a satellite? Do you just look up in space, or do you guess where it is? No, well, you have satellite tracking programs like this one, software, computer software. You have satellite tracking websites, NY2O, for example. So satellite tracking programs are available. They have maps that show the real time, meaning right now, position of the satellite track over the Earth. So you could see if it's coming to Trinidad and Tobago, you could see if it's moving away from, you could see when it's going to be in sight, you know, when the footprint will be over the Caribbean area, Trinidad and Tobago. You could see if you're coming towards acquisition of signal or loss of signal. You could see the direction it's coming from. The time, the azimuth, and the elevation of the start, maximum altitude, and the end of pass are all provided to you using this software. The apparent frequency of the satellite transmission, including the effects of Doppler shift, and we'll talk about Doppler shift in a little while. So all of these things are provided by satellite tracking programs. Again, you need to know this for your exam. One input into the satellite tracking program that you need to know about is KEPS, or what we call the Keplerian elements. Hams like to call it KEPS. Anytime you hear Hams say, "Hey, Anna, did you update your KEPS?" They're talking about the Keplerian elements. That is an input that you have to put in. So if you have a new satellite that you need to track and your satellite program doesn't have the KEPS or the Keplerian elements for it, you need to find out what the KEPS for it is and put it into a satellite tracking program, and it will then be able to track that satellite for you. Now, when you're tracking a satellite, there's something called Doppler shift. All right, so the best way I like to explain Doppler shift is if you're ever listening to a police siren or an ambulance siren coming, you will hear the pitch change as it comes to you, right? And when it moves away from you, you will hear the pitch of that siren change. But do you ever notice if you stand up right by a siren, by a police car, you ever notice the pitch don't change? It is one continuous pitch, right? So that change in the pitch is an example of the Doppler effect. So that happens to any time something is sending out a transmission that is moving. Doppler effect. So Doppler effect is an observed change in signal frequency caused by the relative motion between the satellite and the Earth station. So that satellite is moving so fast that even the frequency of transmission is shifted a little bit, and it shifts differently if it's coming to you or if it's moving away from you. That is Doppler shift. What it means is when you're listening, okay, question. Yes, very good point, Colin. Yes, in the subway, you will hear it. You will hear the train coming, and then when it's going away, it sounds different. But if you're on the train sounds the same. Very good point. Colin is telling us that the Doppler effect is observed in subway stations. If you've been into, let's say, the MTA or in New York or anywhere, right? You may have observed that Doppler effect. Very good point, Colin. Yes. So we sometimes as hams, what that means, you have to actually tune the frequency and change the frequency down or up to cater for Doppler shift. That is what it actually means for you. You have to shift it to listen to and transmit. You have to change your frequency. The other thing that happens when you're trying to communicate with satellites is you need to cater for what is called spin fading. That satellite that you see there, especially amateur satellites, they don't stay, you know, one place and then, you know, moves around the Earth, you know. They're spinning all over the place. They're twisting, you know. They're not necessarily stabilized satellites. Amateur radio satellites are not necessarily stabilized. So they're spinning like mad in space, right? Spin fading is caused by the rotation of satellites and its antennas. So you need to cater for that. How hams do it is if you ever see a ham using an antenna to talk to a satellite, you'll see the ham rotating that antenna like he's going mad or she's going mad. Well, they are trying to cater for spin fading. They are trying to cater for the fact that that satellite is spinning. Sometimes they use different types of antennas, such as circularly polarized antennas to try to cater for it and so on. But we need to know for our exam that when you're tracking satellite, we need to be aware what Doppler shift is and spin fading. Okay, so as amateur radio operators, we also do contesting. And what contesting is using amateur radio to operate, but we try to make as many contacts as possible during a period of time. So you might hear that this weekend is the ARRL contest or the CQ Worldwide contest. You will hear that as hams. And for maybe Friday night into Sunday night, for those 2 days, they are on the air trying to make as many contacts as possible. They're not contacting somebody and say how you're going and so on. They will just simply CQ contest and, okay, exchange a call sign and maybe a serial number and say, okay, thank you. And next person, it's a very quick operation. So that is contesting, contacting as many stations in a short space of time or a period of time. CQ contest, right? Now, a good procedure when you're contacting another station in a contest is to send only the minimum information needed for proper identification. Because what you're trying to do is you're trying to be efficient and effective. So you don't want a whole lot of extraneous or extra information. You just need to send the minimum amount of information to establish the contact in a contest. Grid square locator or simply grid locator is another way of saying where you are. So instead of giving your GPS latitude and longitude or lat and long, as amateur radio operators, we normally give our grid locator. So for example, so what a grid locator is a letter number designator assigned to a geographic location. So Trinidad and Tobago is here in the FK or Foxtrot Kilo region, but you can go down to a granular level. So my location is actually Foxtrot Kilo 90 Foxtrot Papa, FK 90 FP. That is my grid locator. So as a ham, you will have your own grid locator as well. That is how hams tell each other where they are. They don't necessarily use latitude and longitude. They use grid locators, or we use grid locators, and you will use grid locators. Another technique that you use under radio as a ham is direction finding. So this is a directional antenna. You see a ham listening and he's trying to find, he's doing what we sometimes call fox hunting. It's not an actual fox that we're hunting. We are hunting a radio signal or a beacon. and that is a hobby as part of amateur radio to locate that signal, and we use a directional antenna. So radio direction finding is a method used to locate sources of, it could be noise, it could be interference, it could be jamming, it could also be trying to locate it deliberately through something called a Fox hunt. But you just need to know for your exam, radio direction finding is a method used to locate sources of noise, interference, or jamming. And note that it uses a directional antenna. Right, yet other operations on the amateur radio, and I think we'll probably use this slide as the last slide for our class. We didn't touch into any of the questions. I thought we'll take us through the theory, but the questions in the question pool are all asking questions about this theory that we have done here. So when we come back in the next class, we'll certainly we'll go through quickly, or at your choice, you know where we stop. You can go through the questions in the question pool yourself, but we will certainly do that in the next class. So the last slide for today, other options on the amateur radio. You need to know about something called the IRLP, or Internet Radio Linking Project, IRLP. And what IRLP is, you remember we had shown that we could link repeaters wide area across the country or across countries, different territories around the globe. Well, the IRLP is one of those ways to do so. It's a technique to connect amateur radio systems, such as repeaters, over the internet or via the internet using VoIP, or voice over IP protocol. And this is an example here of using IRLP. We have a repeater here, maybe in one country. It's connected to the internet, and another country, there's another repeater also connected to the internet. And this equipment here allows a person in one country to talk to another. And just imagine that there are several repeaters connected in that way through a reflector. And people are talking across the globe using the IRLP, Internet Radio Linking Project. And you need to know for your exam what VoIP is, or voice over IP. VoIP is a method of delivering voice communication over the internet using digital techniques. So if, for example, you have ever used Skype, or if you have ever used Zello, you can say that that is using VoIP technology, or voice over internet protocol. You're using the internet, you're using data plan to speak to someone somewhere, and those techniques are considered VoIP or VoIP. So folks, that's where we will stop today. We have covered quite a bit of material. We are coming to the end of our sessions. So we probably just have maybe about 2 more sessions to go. Our next session, we will try to cover a little bit more of these, a couple more slides that we'll go, and then we'll go through the questions in the question pool on the operating procedures. And then we will do the final topic, which is rules and regulations. And that may take us another class, or we'll see how we go in terms of the pace, but we are coming towards the end. So thank you very much for staying the course, everyone. Our next class is expected to be held on Friday, the 4th of September. So folks, we'd like to say to everyone, continue to be safe, follow all of the protocols, and make sure that we beat COVID-19. We'd like to have you back here for another class to become licensed amateur radio operators and to have QSOs for many, many years to come. So please be safe, you and your family, friends, colleagues, everyone out there. Take good care. Have yourselves a good night.